Unit 8, Day 2 video notes, the elimination method and inequalities. Okay, the elimination method, your book calls this the addition or subtraction method. And I'm going to show it to you as just addition. The subtraction method's just a special case of addition. We just need to change all of the signs and then add. These video notes will be a little bit longer than some of the others because I'm going to give you more examples. I think the examples are useful to have. So first, let's just do one that is pure addition. We have a system of equations, two equations with two variables. And we need to solve these. We have 3y plus 6z equals 3, and also negative 4y minus 6z equals 2. And we have two methods that we're learning, substitution, which you've already learned, and elimination, because some problems it's easier to use one method, and other problems it's easier to use the other. We want you to have both tools in the toolbox. Okay, now if you look at this, you will notice that right here I have, and let me move that so you can see it, I have a positive 6z, a negative 6z. If I was to add these equations together, those two would cancel out. And in fact, that's just what we're going to do. We're going to add the equations. So 3y plus negative 4y, or 3y minus 4y, is going to give me negative y. Positive 6z minus 6z, those are going to cancel. And then 3 plus 2 is 5. So I now have an equation with only one variable in it. I have negative y equals 5, fairly simple one to solve. And I will have to divide both sides by negative 1. And that will give me y equals negative 5. Now, we need some way to keep track of this. We have two variables that we need to find here. One of them my x, and one of them my y. And I just found the y, so I will put the y into my ordered pair, and it was negative 5. Now I need to find the x. And to do that, I'm going to use this y that I already found, and I'm going to take one of these equations. It doesn't really matter which one. I use whichever one's easier. And in this particular case, it doesn't matter a whole lot. But I'm going to steal this equation. And I'm now going to use it to solve for x. Or not x, z. Okay, let me back up here. And this is the very reason to write out what I'm finding. Let me erase this. These equations do not have x and y, they have y and z. So, and you may notice that the variables are always in alphabetical order in the ordered pair. So I have y and z like this. It's y that I found, y is negative 5. Very helpful, particularly when it's not x and y, to write out either above or below my ordered pair which one is which. Okay. So now I need to go ahead and solve this one. So I'm going to substitute. I have y equals negative 5, so I'm going to write 3 times negative 5. And I might add, I'm going to recommend when you're solving these problems that you actually write out the equation with the variables before you substitute. It'll help you stay organized. Now plus 6z equals 3. Now I just need to solve this. Well, 3 times negative 5 is negative 15 plus 6z equals 3. I'm going to add 15 to both sides. And when I do that, I will get these two canceling out, 6z left on that side equals, and 3 plus 15 is 18. Now I just need to divide both sides by 6. And when I do so, I will get z equals 3. So let me come back up here and put in 3 for z, and and I did this again. Let's see if I can fix it. Put 3 in here. It was 3, right? Yes, 3 into my ordered pair for z. Now, well, this would be my answer. However, I'm not done. I need to plug this in and check. It's very important to check each and every problem. We have to check both coordinates in both equations. Very important to check it because it's way too easy to make a sign mistake or another mistake in here. So now my ordered pair is negative 5 comma 3. I'm going to come over here. I'm going to write my negative 5 comma 3. And again, this was y and this was z. And I'm going to substitute. So I'm going to take one equation on either side and take care of doing my substituting. So let's start over here. Okay, let's lengthen the page a little bit. Okay, so now on this side I have 3 times negative 5 plus 6 times 3 equals 3. I'm going to do the substituting on the other side, then I'm going to solve one equation and then solve the other. So over here, I have negative 4y, whoops, back up, I'm supposed to be substituting. So negative 4 times negative 5 minus 6 times 3 equals 2. Okay, so now let's come back to this equation and solve it. Well, 3 times negative 5 is negative 15. And 6 times 3 is 18 equals 3. And negative 15 plus 18, or 18 minus 15, is 3. So I have 3 equals 3. And my solution checks in this equation. So let's now try the other equation. Let's move this down a little bit. So now I've got negative 4 times negative 5. That gives me a positive 20. And then I have negative 6 times 3. So I've got minus 18 equals 2. And 20 minus 18 does, in fact, equal 2. So I have 2 equals 2. And this one also checks. As it checks in both equations, my answer was correct. Now let's move on to another example. This time, we have a slightly different issue. Now, the first set of equations, I had opposite signs but the same coefficient on the 6. I had a negative 6z in one equation and a positive 6z in the other. In this equation, I have a positive 3x and a positive 3x in both equations. We need them to have the same coefficient but opposite signs. So we need to take one of these equations and get the sign changed. To do that, let me clone this and move it over here. To do this, I'm going to take this equation. Actually, let's not worry about cloning it. Let me back up, and I'm just going to move it. Whoops. So I will. Okay. I'm going to have a negative 1 that I'm going to multiply it by. And so that's going to change the sign on each term, making it negative 3x minus 5y, plus 5y. Again, it changes all of the signs, equals negative 5. Again, it has changed all of the signs. And now, get rid of that one. I will delete it. And now I'm going to write this out. I have negative 3x plus 5y equals negative 5. And now we will go ahead and add them together. When we do so, the 3x minus 3x, those cancel. And then I've got 2y plus 5y, that gives me 7y equals, and 19 minus 5 gives me 14. Now I just need to divide both sides by 7, giving me y equals 2. Again, I need some place where I can keep track of my answer. So let's put this in. This time we have an x and a y. Let's put in our ordered pair. And you probably want to use where you write it to make it easy to find. I'm using color as I'm a little all over the board. You have a little more paper to play with than I have here. So now we found our answer for y equals 2. That's our y coordinate. We'll put that in. And now we need to solve for our x coordinate. Again, we can take either equation, whichever one is easier, and plug it in. So I guess I will steal this equation. Let's come down here. And I'm going to bring it right over here. Let's move this so we can see the coordinate that we have. Now we're going to substitute a 2 for y. So we have, oops, (3x minus 5 times 2 equals 5. You'll note that this is exactly the same from this point on down, exactly the same that we did with the substitution method. It's only the first portion of the problem that's different with elimination. So let's go ahead and solve this. We have 3x minus 10 equals 5. We'll add 10 to both sides, giving me 3x equals 15. Divide both sides by 3, and we have x equals 5. So now we need to go back up here and put in our x coordinate of 5. Okay, so we have 5 comma 2. Let's take it over to the next page. Whoops. That page shouldn't be there. And it was 5 comma 2, correct? Yes, 5 comma 2. X and a Y. Okay. Now we'll take each equation and plug it in and check it. So over here, I now have 3 times 5 plus 2 times 2 equals 19. And over here, I have 3 times 5 minus 5 times 2 equals 5. Now, as I have mentioned before, my solution has to check in both equations. If it only checks in one, it's wrong. We made a mistake somewhere. It has to check in both equations. So let's go ahead and do this. 3 times 5 is 15, plus 2 times 2 is 4, equals 19. And in fact, 15 plus 4 does equal 19. So I have 19 equals 19, and it does check. Now over to this one, 3 times 5 is 15. And then 5 times 2 is 10, so I have minus 10 equals 5. And in fact, 15 minus 10 does equal 5. I have 5 equals 5, and this one also checks. Moving on now to the next step. What happens when I don't have the same coefficient with opposite signs, or even the same coefficient with the same signs? Well, I can still use the elimination method. Now, something I didn't mention, in order to use the elimination method, everything has to line up. The variables have to line up. The x's line up, or whatever variable that is. The y's, or whatever variable I'm using, have to line up. The equal signs have to line up. If they don't line up, I need to move the equation around to get them to line up. So in other words, I need to add a term to both sides, subtract a term from both sides, whatever it takes to make it so that they're in the same form, so that they line up. Okay, so in this case, if I look at this, I'm going to notice these right here. If I took the negative 5y and I multiplied it by 2, I'd have negative 10y, and then I could use elimination. So that really is exactly what I'm going to do. I'm just going to take that whole equation, both sides of the equation, and multiply it by 2. It will still be equal because I've done the same thing to both sides. So let's go ahead and take a look at what that looks like. Let me move this equation over here, and I'm going to multiply both sides by 2, giving me 8x minus 10y equals 10. So let's recopy this over here. I now have 8x minus 10y equals 10, and I can go ahead and add. So now 8x minus 3x gives me 5x. Negative 10y plus 10y, those are going to cancel each other out. And 10 plus 15 equals 25. Divide both sides by 5. And x equals 5. Okay. Gee, I need a place to keep track of this. So let me put in my x and my y here, make my ordered pair. And I've just found my x coordinate is 5. Here, let me change the color here. I'll back up, change it to black, make it 5. Okay. So now I need to take one of these equations. Again, it really doesn't matter which one. Whoops, I moved to a different page. Where am I at? Okay, back where I'm supposed to be. So I'm going to take one of these equations. I think I'm going to use this one. Bring it down here. And here, let's move it over here. And I'm going to plug in that 5 for x. So now I have 4 times 5 minus 5y equals 5. Okay, 4 times 5 is 20, minus 5y equals 5. I'll subtract 20 from both sides, and that'll give me negative 5y equals negative 15. Okay, divide both sides by negative 5. And y equals 3. Okay, let me come up here and put this into my ordered pair. A y value of 3. Now let's take it over to the next page and check it. I've got 5 comma 3. So over here, 5 comma 3. This is my x and this is my y. Put one equation over on this side, one equation here. So here I have 4 times 5 minus 5 times 3 equals 5. Oh, and just a warning, make certain when you're substituting that you substitute the values in for the right variables, particularly when the equation is not in standard form. I've seen it happen many times where students accidentally substitute the coordinates in for the wrong variables in the equation, and then it doesn't work. So now I have negative 3 times 5 plus 10 times 3 equals 15. Okay, so let's come over here. 4 times 5 is 20. 5 times 3 is 15. Equals 5. 20 minus 15 does in fact equal 5. And 5 equals 5. That one checks. Now let's try this one. Negative 3 times 5, negative 15. And 3 times 10 is 30. Plus 15. Okay, negative 15 plus 30, or 30 minus 15, is 15. And 15 equals 15. This one checks as well. Okay, now, let's take a look at this. Well, gee, If I look at that one, I can't just multiply one of these by something and get the same coefficient but different signs. And the same thing applies over here as well. I'm going to need to multiply both equations by something to get this to work. And really, I want to multiply by the smallest numbers I can. So I'm going to take this 3a and 5a and make them cancel. So I'm going to take, let me move this over here. I'm going to take this equation and I'm going to multiply it by 3. And I'm going to take this one and I'm going to multiply it by -5. That way I'm going to end up with positive 15 with one of them and a positive 15a on one and a negative 15a on the other, so that they will cancel, they will eliminate. So let me go ahead and do this. Now I have 15a plus, well, 3 times 9 is 18, so 18b equals 3. And over here, I now have negative 15a minus 20b equals -10. Okay, so I'm going to take this equation that I have in green and I'm going to move it over here under the other equation so that I can do my addition now to eliminate. So I have negative 15a plus, no, sorry, it wasn't plus, it was minus. Let's try this again, 15a, that's better, it's more legible anyway, minus 20b equals -10. And so now when I add them together, my 15a and negative 15a will cancel. And I'm left with 18b minus 20b, which will give me -2b equals, and 3 minus 10 is going to give me -7. Did I make a mistake here, or am I going to end up with a fraction? I'm thinking I made a mistake somewhere. Perhaps I didn't. -20b, -10, 3. I end up with 7. I'm going to stop this right here. Okay, I found my mistake. 3 times 9 is not 18. Three times 9 is 27. So I have 27b here, which will make a difference in my answer. So let's take out this -2. And that should now be a +7. Okay. Now, it doesn't mean that you won't end up with fractions. I just happen to know that this one didn't. And to be honest, most of them that you're being given probably won't, although it's certainly possible to end up with fractions. And in fact, many equations, maybe most equations that are out there in the real world do. But let's keep going with this now. We need to divide both sides by 7. And so b equals -1. Again, I need some place to keep track of this. And I'm going to cheat a little bit. I'm going to move my title over, and I'm going to put in my, oh, in this case it's A and B. Let's use colors again, A and B. Put in my ordered pair here. And the one that I just found is B, and B equals -1. Now I need to find A. So again, I will use one of these equations, whichever one is easier to work with. I think I'll grab this one. In many cases, it doesn't really matter which equation, but sometimes one is obviously easier than the other. And now I'm going to substitute, whoops. So I'll put that where I want it. Now I'm going to substitute in this -1 for B. So now I have 3A plus 4 times -1 equals 2. Okay, so that means 3A minus 4 equals 2. I can add 4 to both sides of the equation of the equal sign. And when I do this, I'll end up with 3A equals 6. Divide both sides by 3. And A equals 2. Okay, let me take this up here and put it in my ordered pair. A equals 2. So I've got 2 -1. Let me take it to the next page. 2 comma -1. This was, whoops, not X and Y. 2 comma -1. And it's A and B. Let's take one equation to that side, one equation to this side, so that we can plug it in and check it. So over here, I have 3 times 2. Let me fix that so it is easier to read. 3 times 2 plus 4 times -1 equals 2. And over here on the other side, I have 5 times 2 plus 9 times -1 equals 1. Okay. So 3 times 2 is 6. 4 times -1, that's going to give me a -4, so -4 equals 2. And 6 minus 4 does equal 2. We have 2 equals 2, and that one checks. Let's try the next one. So 5 times 2 is 10. And then that's going to be -9 equals 1. And 10 minus 9 does in fact equal 1. 1 equals 1, and that checks. Okay. Moving on now to another subject. Order of numbers. We're talking really about using inequalities. So this example that they gave us, 4 is greater than -7. We've got 4 is greater than -7. How do you remember this? Well, when I was in school, they said the alligator eats the bigger one. Some of my students have told me that they were taught the Pac-Man eats the bigger one. Well, Pac-Man was a little after my time, so I didn't learn it that way. But another way to think about it is by the distance apart in the symbol. The side where the number is larger, the top and the bottom of the symbol are farther apart. Just like you'd do with your hands if you were indicating something big. You'd have them far apart. And on the side that's smaller, the top and bottom of the symbol are close together. Again, like you would do with your hands if you were indicating something small. Less than, of course, is just the other way. And then, of course, there's greater than or equal to, and less than or equal to. Okay, we'll talk more about those as we move on here. So, next one here. We have this 3 is greater than 2 and less than 5. So 3 is greater than 2. That's pretty easy to do. 3 is greater than 2, meaning 3 is bigger than 2. No problem. And let's see here. And what is less than 5? Well, it's this 3. 3 is less than 5. So 3 is less than, yes. And 3 is less than 5. Is there another, maybe more efficient and neater way we could write this? Yes, there is. 3 is in both of these. What if we put the 3 in the middle? If we did that, we could write 2. And now that 2, the smaller one, is on the left, we have to flip the inequality so it says less than. So 2 is less than 3, which is less than 5. Okay, and there's a way that we read this. We read this as 3 is between 2 and 5, which it is, because we have the smallest one, which is less than 3, which is less than the largest one, 5. Okay, so similarly, now we have 3 is between 2 and 5, 3 in the middle, the smallest one, 2, is less than the one in the middle, 3, which is less than the largest one, 5. That's 3 is between 2 and 5. And that's the way we actually read this. Now, just a warning, if the inequalities were flipped the other way, that doesn't work. Unless we also were to flip which end the smallest one and which end the largest one is on. And we don't usually do it that way. We usually go from smallest to largest and use less than symbols. Okay. So now we have an inequality right here that we need to solve. Extend the page so we have room to play. And we subtract 3 from both sides of the, in this case, instead of equal sign, of the inequality. And that gives us x is less than, and 11 minus 3 is 8. So x is less than 8. Now, they want us to graph this. How do we go about doing that? Well, first thing is this doesn't say less than or equal to, it just says less than. So I need to make sure, that 8 is not included in my answer. So I need to use this circle that's open, indicating that that's not part of the answer. If it was less than or equal to, I would use this one here that's closed, indicating that it is part of the answer. Now, less than 8. That means we're going to go with all the stuff that's smaller. So like 7 and 6 and 5, and all the way over here to negative 11. So we need an arrow that points in that direction. I'm going to put it here. And let's see if I can whoops, didn't do what I wanted. Undo. Let's try it again. And I'll come over here to do it. And I'll lengthen it all the way out. So now I have graphed x is less than 8, Let's go ahead and try another one. Now I have negative 5w is less than or equal to 15. And there's a little piece that we didn't run into with the other one. The other one was just like working with it as if it had an equal sign. This one actually is like it too, except there's something that we've never had to deal with an equal sign that we do here. So let's see, we need to divide both sides by negative 5. So over here, the negative 5s are going to cancel out, and I've got a w. And over here, I'm going to get a 3. But there's an issue. Multiplying or dividing by a negative number flips the inequality. In effect, what we've done is we've created a mirror image of this inequality on the other side of 0. And so now, instead of dealing with a negative 5w, a positive 15, we're over here at, instead of being at a negative 3, we're at a positive 3. I'm saying that wrong. But we're flipping the inequality. We now need to write it as greater than or equal to. And we have, in effect, created a mirror image of it. Now, when we multiply or divide by a negative number with the equality, an equal sign, we, in fact, actually flip the equal sign. It's just that flipping the equal sign doesn't change anything, so we don't talk about it. But with an inequality, we need to flip the inequality if we multiply or divide by a negative number. Notice that adding or subtracting doesn't flip the inequality, just multiplying and dividing by a negative number. So now I have greater than or equal to, so I do need to include the 3. And so I need this, whoops, where am I at? I need this dot over here on the 3. Oops, and I moved the wrong piece. Let's try it again. I need this dot over here on the 3 to indicate that the 3 is included. And then it's greater than or equal to. So I need to point toward the larger side. So I need this arrow.